Good morning, everyone. Thanks so much for joining this session, which I'm really excited about. Just want to set the scene. You know, we're at a fascinating crossroads in AI. Open source models are accelerating innovation at breakneck speed. Agentic AI is reshaping how machines interact with the world and each other, and investors are racing to back the next foundational shift in AI. At the same time, the global race for AI chips is becoming as strategic as the models themselves, reshaping supply chains and national priorities. So what next for open source AI, the chips that power it, and what that means for where investors are looking to put their money? I'm very excited for this session with what is a very wonderful panel. And I just want to kick off the session. Rodrigo, I can start with you. We're seeing such an unprecedented pace of innovation in AI. What has been for you some of the biggest shifts technologically over the last year or so?
Well, I think what we've all seen is this very fast shift towards inference and production inference, and so that's exciting because I think you're gonna have AI be accessible to a lot more people, but probably even more so is how fast these agents are going into production. And so we're seeing folks take these agents and deploy them very quickly. I actually think it's gonna go to production faster than the larger models just because it's easier to prove and test. And so I think you're gonna see that accelerating, and with that acceleration, I think you're just gonna see so many more use cases that you can actually then generate ROI in the business.
And from your perspective, Tony?
I think the main narrative, we've gone from chatbot to superintelligence wars. It's a race for superintelligence now, and this is total war. So this is to build the whole stack, from compute to models to agents, and the ambition has been elevated. So we're not just talking about simple chatbots. It's a race. I think you mentioned that. It is a race for achieving superintelligence, and that comes with huge sustained investment. And I think that's the biggest change. The totality of it is at a much higher level.
And Thomas, from your point of view?
So I think it's a war, like Tony just said, but it's an interesting war because we keep trading soldiers with the opponents, right? So there is this really interesting thing where it's a race, but actually all the top players are really close to each other, and the general knowledge about how to build good models just keep diffusing more and more, right? So we do a part of it during open source and sharing knowledge, but generally there's this big tension between doing everything closed and then trying to do everything open, and can sometimes help you leapfrog other competitors. So it's a very interesting type of war dynamic, I think.
Tom, let's get on to our first big topic, which is open source. You know, you have great visibility into this at Hugging Face. We've seen the capability of open source models very, very advanced, matching some of the proprietary models as well. But when we hear about business adoption and adoption of these models, a lot of that's still focused around these closed proprietary systems. So where do you see at this moment the sort of benefits and challenges of open source as it comes to sort of broader, widespread business adoption?
So I think the first thing to keep in mind, I think, is we are still not really at the steady, like stabilized state. So we're still really in a moving landscape, which means you have like this frontier of capabilities. For many, I don't know how much. It's hard to really put percentage, but for definitely some of this usage, in particular the more B2C, you really want to sit at the frontier. So which means the companies like, I don't know, like Lovable, Bold, Vibe Coding, Cursor, they really want to sit at the frontier of capabilities. Now, what I think is we pretty much everyone agree we have like a general increase of both frontier models and then the open source model staying not so far. And the reason the open source models stay not so far, I think, is you need much more capital to actually open the way than walk in it, than walk after. It's a little bit like when you walk in snow, right? You're the first one walking and making the trace. You spend a lot of efforts. That's exactly how it works. But copying, and we saw that really well with DeepSeek and reasoning model, copying the knowledge is quite fast. And so we always have that. And I think what my feeling is as we start to settle down a little bit more, we'll see more and more, people being able to use open source model with decent capabilities for what they want to do. And then you have obvious advantage. You can use custom chips. You can actually lower the cost. You can control where you want to deploy them. You can control the latency. You can control privacy and the model. You can fine tune it. So there's a lot of advantage in the end for open source. But a little bit like in software, I think open source is more playing the long game than the short-term game.
And Rodrigo, from your perspective, you've got the software stack, you've got the hardware stack as well. So when it comes to enterprise adoption of open source, what are you hearing? What are you seeing?
Well, I think it's true. I think you got a lot of real great innovation in the open source community. I think depending on what you're doing, I think the closed source models are still better in certain attributes. But what we see is certainly the cost is better for the open source models, and I think you see a lot of people using it for that reason. But probably more than that, what we see it for enterprises is that there is a tremendous amount of data that sits with enterprises that they don't want to disclose to the model makers. And so for them is they want to leverage that data, and the open source models allows them a way to actually train that private data into a model and retain ownership of the model forever. Right, and that's a concern for a lot of folks. Like, if I take them data and actually train into a model, can I retain that model in perpetuity? And so we're finding that there is a lot of interest for folks that want to create their own model, their own asset. They don't want to do it from scratch, 0 to the 90%. I can take a very good base model that's open source, then adapt it with whatever data and create my value add. Right, and so we see that a lot and that's true in sovereign. That's true for companies that want to differentiate with their private data, vertically or organized services, as well as highly secure, highly private organizations where you're regulated and you don't want to disclose that data outside your domain. Then you need open source again.
And Tony, how do you see this matrix playing out between open source and these closed proprietary models?
Well, the facts are right now, proprietary is ahead. I don't know what, Thomas, you would know because you guys have 500,000 open source models on your site, but
4 million.
4 million, sorry, 4 million. I was off by order of magnitude. There is a lead. I don't know if it's 6 months, 12 months, but there is a performance lead. And I agree with your statement. Open source is the long game. Cost, accessibility, et cetera. But in the here and now, proprietary has the lead. And especially in the early days of agents, and we'll talk about that, and big enterprise, for example, the business side, performance, accuracy matters more than, I think, cost in the initial phases. But as this thing stabilizes, and then I think that levels the playing field. And open source, like iOS, Android, or Linux and Windows, like there will be a open source variation that will solidify. But in the early days, clearly, it seems to me that the proprietary models are, and the APIs that they're serving are, and the usage has favored the proprietary models right now.
Tony, is there a moat possible around models? Because there is a view in the market that actually ultimately this is all just going to be commoditized. The value add's going to be on the application layer. So as you look at the AI landscape, all the way down to the chips, up to kind of models, where do you see kind of the defendable moats?
I've been going back and forth and back and forth. Models a commodity, models not a commodity. The mode is in the chips, mode is not in the chips, mode is in the app layer, mode is not. You go back and forth. I mean, in these 3 years, I've been going back and forth where the mode is. But increasingly, I think there will be a coexistence. There will be this Linux-like open source model world. And this will be a pervasive ecosystem in architecture. But at the frontier, I feel to control your destiny, you must be a player at the frontier, at the model layer, and at the compute layer. And these are interlinked. And then that allows you, kind of like in operating systems today, it allows you the right to win and then to build apps and agents on top. So a full stack, like that total war analogy, I do think controlling your own destiny in the foundation model game can be extended. And this is what you're seeing, in my opinion. Why you're seeing what my first statement is. This is the change. That's what I've observed in the last 12 months. Is that view is what is being expressed in these biggest tech companies in the world. Is a race to have that.
And Rodrigo, for a startup like yourself, you are attempting to do here what Tony is saying around the compute, around the software and model side of the equation. In the area you're playing in, particularly when it comes to areas like inferencing, how competitive is this getting right now? Because every other week I'm seeing a new chip startup pop up in this space. And how do you defend what the moat you're trying to build?
Well, I think the game of inference to me is going to be about access to computing, right? And so if it's about who can get as much access as possible to deploy their services, deploy their models, deploy their applications and agents. And so, but we all know computing is getting more expensive. It's getting it requires energy. You got gigawatt data centers, nuclear power plants, and all those things are getting built. And so I think that's going to be our constraint. So for SambaNova, we're very focused on democratizing that. How do I actually take what's otherwise 140 kilowatt rack and dropping down to 10 kilowatts per rack so that everybody can get access to it? So my advice to a lot of people who are trying to build their own services, and like Tony said, control your own destiny, at least part of your solution you can control by saying, I will just own the infrastructure. Right? I don't need a gigawatt data center because we can go to suppliers like SambaNova and get a 10 kilowatt rack and deploy some of it within my own control. And so that's our moat. But for our customers who are doing that, my belief is their moat is around building models that leverage their data. And a lot of data today sits on-prem and sits in places that you don't want to disclose. And so we have to create technology that fits within that power envelope because you're not going to be able to actually move that data into places where the computing is available. And so I think this interconnection between where the users are, where the models have to deploy it, and where energy is available is going to become an increasing problem for us. And so for us, it's all about how to actually reduce the footprint that's required to deliver that level of computing so that you can actually make it accessible to everybody.
I want to come back to the inferencing point, but Tom, I just want to get to you very quickly about where you see the moats right now in AI as you sort of assess the landscape.
Yeah, I think it's really difficult to form a strong idea on this. So for instance, right, one of the surprising thing about this technology, if you compare to SaaS business, for instance, is how easy it is right now to switch from one model provider to the other. And we see many companies constantly benchmarking them against each other and being very, very easy to switch to the new one. Cloud 4 come out, we'll go there. GPT-5 might come out, we might see all of them flocking. We have the same in open source, of course. So that's one of the issue I would say with open source, which is when you open source model, it has like a lifetime of maybe 6 months, 7 months. Though maybe to be honest, I should nuance this because when you look at all the most downloaded models on Hugging Face, it's really surprising to see that some pretty old models are still really in the top. And I think this is one thing is also at some point when you have like a working workflow, you actually don't really want to update it. So that's a problem with closed source, which is you're forced to move because they just don't keep the old models alive. GPT-3 is deprecated, GPT-3.5 is out, all of them are out, so you're kind of like the Apple iPhone. You're forced to update all your things constantly all the time. And that's of course a challenge that open source helps solve. But yeah, I think this moat is tough. I think that might be one reason also we see many of the players moving more to hardware and trying to see if there is a mode to solidify there with OpenAI, Microsoft, AWS building something there.
Let's get back to inferencing then. Rodrigo, let me come to you quickly. What is it in the next 2-3 years, beyond just raw performance, that are going to be the key competitive battleground for chips that are specifically focused on inferencing? That's the first part of the question. Second, NVIDIA obviously has become the very gold standard for training. And Jensen Huang has made it very clear that he believes NVIDIA can be a huge player in inferencing. So in that case as well, how do you expect to compete with a giant like that?
Well, the first part, I think what we know is there's this trade-off between having the models running and running fast, right? And so most of us, as the models are getting bigger, the systems, the servers are running less and less efficient, right? Just because you're swapping those kernels all the time, and then as you go into agents, the more agents you have, the less efficient those servers are running because you have to load and unload these models, or you have to kind of have them queued up waiting for the prompts to come in. And so, so one of the most important things that we're seeing is you gotta drive efficiency up, right? That the cost and the power of actually running these large agentic systems cannot be sustained, and it's going to be a blocker to scaling, right? And so that's what inference, as the world is moving into these complex agentic solutions, we have to solve that utilization problem of hardware, because we can't just brute force our way by just buying more hardware and putting it out there. And so and we've got a couple of really exciting things we're doing with multi-tenancy that allows us to bring many models into a single environment, allow you to swap them, and drive utilization up. But I mean, look, on the second questions around Jensen, I mean, look, NVIDIA is an incredible phenomenon right now, right? If you look at, I've been in chip design business for 30 years, and you look up, and the most valuable company in the world is a chip company, right? And so, pretty amazing. And I think they're going to play. And yet, I do think that when it comes to this market was inferencing, and you talk about power, you talk about energy, multi-tenancy, all those things, there are going to be lanes that allow other players to come in and play, right? Because as a large chip supplier, you have to focus on kind of what where the big pockets are. And I think there are some high performance, high security use cases that I think other players like SambaNova could play.
Tony, yeah.
Well, I think we spent a lot of time discussing training, inference, and the distinction. Ultimately, it's compute. And we're going from a pre-training regime to a post-training and test time regime. And all the reasoning is in the test time, right? And so, but this is data center compute. And I just look at that as a totality of a compute budget, and in the end game here, as the world goes more and more, the biggest unlock has been reinforcement learning for these reasoning models, right? And that's where most of the innovations and unlock, and that requires a lot of inference compute. And so what do I think? You've got NVIDIA, they're going nowhere. And then you have a bunch of companies trying to build their own silicon. You have the startups, and then you have 7 or 8 other big hyperscalers that will try to build the silicon. Not all will succeed. And then the ultimate game is, what is that end state of who of the startups, of NVIDIA, which is going nowhere, and then of the neoclouds, hyperscalers that will try to build their own silicon, what ultimately happens. And then there, you want to tune your model to your inference fleet. And this is where also open source, again, when it stabilizes, you can, if you have a low cost, highly optimized, highly efficient inference fleet, then you can run at scale at a cost advantage. But we're not there yet. We're still trying to figure out what hyperscaler silicon will work, which model will win, et cetera. And so we're still in this early exploration phase before the thing settles out. But I think that will, and then at that point, when these agents and things, the inference compute, the size of that fleet will be orders of magnitude bigger, and there'll be plenty of room for open source and other custom silicon players, in my opinion.
I think one of the reasons this revolution, in particular in silicon, is very different from the previous one, I think, is the main driving factor is this number we call the price per token, which is up to the really top level, like CEO, CFO level, people are aware of. And if you think about it, that's an extremely low level measure. It's measuring basically one forward path, right? That's extremely low. You can associate that to the number of calculation. We never had that in previous revolution where we say, oh, the CPU is really, we'll do 10 operation, and the price of this 10 operation will be our main driving factor. Never really happened like that. So right now it means this number, I think, is bound to become increasingly important and basically guiding all direction. That's the reason you cannot just get, one company there. There will be a strong push on this price, which is the main thing.
Don, when it comes to fast, sorry,
One,
Johnny,
one
go
more
ahead.
on the inference. This is all in the context of data center compute. You know, if you believe in the humanoids and the physical AI, that's an inference fleet as well. That is in device inference. So you're going to have a proliferation of a different kind of silicon that's going to run in those devices.
And Thomas, from your perspective, what's the role of models when it comes to fast inferencing? Because, you know, we've spoken before about bigger models, but actually, you know, I know at Hugging Face you're working on smaller models. So what does that sort of model matrix look like between sort of bigger and smaller models and the ability to do faster inferencing as a result?
Yeah, I think right now we have three main like models, like three main peaks in our attention matrix. The first one is very large models. That's like 1 to 10 trillion parameters. That's mostly closed source model, this one. The second one I would say is a pretty large open source model that are gathering interest. These are the DeepSeek. This is like sub-trillion for now. And they're pretty good. They are close to the frontier. And then the other strong attention point is the smaller models, like, and this has been a rise since last year. It's pretty recent that we think we can do a lot in 3-4 billion parameters. And one reason it's pretty recent is that it has not really been pushed by closed source company. The main reason is they don't really want you to host the model. They want you to pay for the tokens because that's how their business model is structured at the moment. But what we started to discover since last year, and it started at Microsoft with Phi, and then there is a couple of really strong teams. We were talking about the Quant team. They've been leading that, basically showing that if you train this model better, if you train these small models in smart ways, you can actually get extremely impressive performance out of them. So you'll never like solve the Riemann conjecture. You never do like frontier math problem. But it's also pretty clear for a lot of business use case, you don't really need a model that actually solves complex math problem, right? There's a lot of things that are just data wrangling. You want it to convert the CSV in an Excel file, and that's actually super useful. And so all of these things can run on the edge. And related to that is, of course, in robotics, you have very strong constraint. You want definitely your robots to have some kind of embedded compute capabilities as complex as possible. If your robot is running on the floor here and it loses the network, you don't want it to just fall or run in the crowds, right? So you want definitely something that's pretty smart. And the discovery is that if you use like a 3B or 4B VLM, so image text model, you actually can start to have very interesting capabilities, generalization, world models. So I think this is bound to grow, I think, over the coming years.
Great. Our final part of this session is around agentic AI. One of the biggest buzzwords this year for sure in the industry. Rodrigo, from your perspective, what does agentic AI look like to you? And from, I guess, the hardware, the infrastructure perspective, what are some of the key features that can support those agentic workflows?
Well, I think it's going to be about, I mean, we've talked about it, I think it's going to be something you've got to democratize. You're going to, I think this AI wave is not going to be only for those of us in this room, of those of us that have been kind of doing this for the last 5-10 years, but I think the entire planet is going to do it. So we've got to find a way to democratize it, and that means got to drop the cost down. You've got to drop the challenge of access and making it easier for people to use. And probably the most important part on that is the expertise piece. And so one of the things that we actually announced today is this concept of Samba managed. And so we think there are a lot of partners out there, data center players that want to be in the AI space, but they can't find the expertise or can't find the knowledge on how to be a token factory, how to be a agentic factory. And so we're actually now deploying these full end-to-end pods that allow you to be able to be part of the game. And so I think you got to find ways to democratize it, make it easier, make it faster, so you're in the game faster. You're not waiting 2 years to be in the game. You can be in the game within 60 days, and so that you can start that journey. I think that's going to be how this agentic wave comes. It cannot be one for just a small number of people.
Tony, you spent some time with a lot of tech companies recently, including NVIDIA as well. What were they telling you about how they believe this agentic revolution is going to play out?
Well, I think I look at it like there is the consumer, and then there is enterprise. And I think most of us, we all talk in the context of bringing agents into enterprise. But before I talk on that, I think you have yet to see the real wave of agents for consumer. Like it is clearly the ambition of all the big consumer internet properties to have an agent as a personal assistant. But it extends beyond that. You will see agents that will do your taxes for you, agents that will do your accounting for you. That, I don't know how many of you have agents doing your taxes, but that has not yet fully been diffused into consumers. But that wave is coming. Maybe it's next year, or maybe it's starting now, but it's the early genesis of that. I don't know how many of you have your iPhone as your personal AI assistant, but that is kind of what is on the roadmap. So on the consumer side, that definitely is the ambition. On the enterprise side, I happen to be building an agent. I've been for the last 18 months to do an AI agentic, it's called Asimov, to do financial analysis. A financial analyst agent that would replace myself. And that is, once you get into the enterprise, you get into the guts and plumbing. You got to rewire all the enterprise, and then you got to bring this thing into your enterprise. It's not easy. But it is. That is the wave that's coming, and every SaaS company on Earth, every single SaaS company on Earth will either go extinct, or they will implement and convert themselves into an agentic application.
Tom, from your perspective, what are some of the most promising or exciting applications for agentic AI as you see it?
Yeah, I think this prospect about basically solving all this really annoying part of our daily work life, which I think is very great thing. Like we were talking, and that was 10 years ago, about these bullshit jobs where you basically just do things that don't really matter. I think a lot of the work we do is also just wrangling things around. So I hope this will really let us basically focus on the creative part, and actually sometime we talked about that last time. We talked about that. I really think the creative part is something we still have really a lot of time before AI automate this part, like the part that we really find interesting things to explore.
We've got about 3 minutes left, so I just want to end on a couple current and future-looking questions. We've heard a lot of very exciting things, but as a journalist, I always love to insert a dose of skepticism, of course. What would you say, and Rodrigo, I'll start with you, what would you say are some of the biggest risks as you see them right now to the development of AI? Is it around valuation and these insane seed and Series A rounds we're seeing, and the ability for investors to get burned here? Is it around just some of the hype just doesn't materialize and that hits confidence? Where do you see some of the biggest risks?
Well, I mean, from an investor, I don't know about the valuations. As an entrepreneur, I actually always think the valuations are too low. So, but I do think that if you're gonna think about this, I do think we talk about the energy crisis that's coming. I think we need to solve that. I do think the next one, it's all around data privacy security. I think there is a lot of data that's actually in people's hands. They want to be confident that as it's leveraged into AI, it's secure. And so that's going to be a huge problem. And I think the breaches that kind of get exposed in the next year or two will really be a big risk for a lot of companies.
Tony?
I don't feel valuation is the issue. Even though I want lower valuations, I don't think. But to me, the biggest risk is, will the rate of improvement at the frontier. To me, I always focus on the frontier, and then everything diffuses down from the frontier. Will the rate of improvement sustain itself, and do we need new unlocks to sustain that rate of improvement at the absolute frontier? If that starts to slow or bottleneck, then that is a problem, and then that diffuses down to everything else. So I just focus on that, really, and that would be my concern if we were to slow down.
And Tom?
So on my side, I think the rate of improvement at some point will have to stabilize also because it will be harder to measure. But I really think we're still in this turbulent transition period, and valuation are a good example. I think it's kind of worrying that the only exits we see right now is the gigantic acqui-hire. I don't think it's very healthy that everyone index on this type of thing as a way to evaluate companies. But more generally, I think I'm mostly worried about social impact. I think like this is going to change a lot of things. I think it's moving much faster than basically our governments or like civil society is really handling. I don't think there is